By the end of this video, you should be able to apply this theorem to solve both basic and similarly difficult problems in circle geometry. The theorem goes thus: says that the angle subtended by an arc of a circle at the center is twice the angle the arc subtends at the circumference. First, we need to identify the arc. The arc is a portion of the circumference of a circle. So if you decide to pick a portion, I'm cutting this part and this part. So from here to here, we have an arc. So the angle this arc subtends at the center. So here's the center. The angle we have right here is the angle subtended at the center is twice the angle this same arc subtends at the circumference. So basically, we have an angle here, and it means that what you have here and what you have here, the relationship is one is twice the other. The one at the center is always bigger than the one you have at the circumference, so which means that if this is 2 alpha, this is going to be alpha. Now this is just basically the relationship between both of them. So in terms of value, if this is let's say 15 degrees, what you're going to be having at the center is going to be 30 degrees. Now, this is not just peculiar to minor arcs, because if you look at what we considered here, is a very small portion of the circumference, which we refer to as the minor arc. What happens when you have a major arc? That is, if we consider the other part, the larger part of the circle, that is, if it runs from here all the way around to the other side, we have an angle subtended at the center. Remember, it is drawn this way to make it correspond to the fact that it is a major arc. So the angle subtended at the center, okay, by this major arc is twice the angle it subtends at the circumference. Again, if this is 2 alpha, this is going to be half of that, which is alpha. Now, the direction at which some of this relationship goes sometimes might be somewhat tricky. In the first case, where we had a minor arc, remember we said that the angle subtended at the center is twice the angle subtended at the circumference, but the angle subtended at the circumference does not necessarily have to be at the top, just like we have it here. It could be right on the side. Okay, and then this could also go this way. All of this is at the circumference, this is also at the circumference. So the same thing goes, this is 2 alpha, and this is alpha, and this is also alpha. Now let's solve some questions on this. In the first example, we have to find the value of D. D is the angle at the center, 35 is the angle at the circumference. So basically, the angle at the center is twice the angle subtended right there at the circumference. This is equal to 70 degrees. So you can just write it in front that the angle at the center, or subtend at the center, is twice the one at the circumference because of time. Here, we are given the angle at the center, and now we're asked to find the angle at the circumference. So instead of multiplying by 2, we divide by 2. So y equals 104 degrees divided by 2. Y equals to 52 degrees. The same condition applies. In the third example, we have to be careful here, because it doesn't follow exactly the same pattern as the first two that we've had. In this case, we have an angle, of course, at the center, and then we have another angle at the circumference. But the angle subtended at the center here is for a different arc, and the angle subtended at the circumference is from, which means that the 114 and the angle n are not from the same arc, unlike the first and the second case that we considered. In the first case, this is the arc they are talking about. In the second case. So in the first case, this is the arc that they are talking about. But in this case, we have two different arcs, right? So for the larger arc, we have angle n, and for the smaller arc, which is this one. Okay, so let me just draw it. So from here to here is what produced the 114, right? And from here to here is what produced n, which is at the circumference. So basically, they are not the same. Okay, so what do we do here? What we have to do here is just to produce an angle that is here that we can match up with angle n. So what you do basically here is you say to find the angle that is here, let's call this angle m. So we know that m and 114 degrees are angles at a point which sums up to 360 degrees. So which means m is equal to 360 degrees minus 114 degrees. So m is equal to 246. Now if this is 246, you can now match your 246 with angle n, because both of them now are angles subtended by the major arc, just like we had it in the first explanation that I gave. So which means that this arc, okay, is what the angle at the center, 114, right? And m, which is 246, and the angle at the circumference, which is n, right? So which means n equals m divided by 2. So this is 2460 divided by 2, which is 123 degrees. Now, we have one more example. In this example, we have to find the value of m and n. You can try this because it's straightforward. M is equal to 70 multiplied by 2, which is 140. If m is equal to 140, we can easily calculate the reflex angle produced here by subtracting. So let's call this Q. So we know that Q is equal to 360 degrees minus 140 degrees. Q is equal to 220. Remember to add that the relationship here is angles at a point. Right. So to find n, you just match this and this together. N equals to 220 divided by 2, which is 110 degrees. Now, one last thing before I end this video. You might still be confused about certain calculations or how to recognize which is which and what is what. Let me show you something. In the point where we are trying to say one is at the circumference, one is at the center, if you notice that the orientation of the arcs that we use to mark the angle, here we have angle D, right at the top here we have 35. You're going to see that somehow both are facing the same direction, right? If you look at this 104 and Y, they are also facing the same direction, kind of. Now if you look at the question we had here, the question was of this form. We had n here, and then we have 114 degrees. If you notice it very carefully, you see that they are not in the same direction. The angle marking 114 goes this way, the one marking n goes this way. So which means in this case, something has to be done for you to proceed. The same thing is happening here. If you look at it carefully, you see that m and 70 seems to be facing the same direction. So all you just have to do from there is to identify which one is at the center, which one is at the circumference. And for N, the angle marked Q and N seem to be on the same direction. So you can pair those together. So that's it.